So picture this for a second. You're sitting at your desk, moving your mouse, typing away, and perfectly controlling a highly sensitive computer. But that computer isn't under your desk. It's actually sitting like over 6 miles away.
Right, which is just a massive distance when we're talking about zero lag.
Exactly. So today's deep dive is into a technical spec sheet for this really heavy-duty piece of hardware. It's called the Smart-AVI P2P-KVG302 IPGard extender. And our mission today is to cut through, well, a whole wall of tech jargon and figure out how massive mission-critical control rooms actually pull off this kind of remote control.
Because when you think about it, we all know that frustrating, sluggish feeling of a standard remote connection. I mean, the mouse trails behind your hand, the video gets blocky.
Oh, yes, the worst.
Yeah, but the technology that eliminates that lag entirely, that is what keeps our critical infrastructure running safely every single day.
Okay, let's unpack this. The core function here is moving data over a standard 1 gigabit Ethernet network. But it's not just sending a few simple keystrokes, is it?
No, not at all.
Because the specs list high-fidelity dual-head DVI video up to 2560 by 1600 resolution at 60 Hz, plus transparent USB 2.0 and analog audio. I mean, that is just a massive data fire hose to push through a network.
It really is. Shoving 2 uncompressed, high-resolution video feeds, plus your keyboard and mouse inputs down a single cable that normally just chokes a system completely.
Yeah, I'd imagine.
And what's wild is the physical distance they are pushing this fire hose. So
Right.
on standard copper CAT6 cables, you get about 328 feet.
Okay, pretty standard.
Right. But then you move to multi-mode fiber optic, where the light kind of bounces around inside the cable, and you reach over 1,640 feet.
Wow. But then there's single-mode fiber, because that's where the spec sheet says it hits 6.2 miles, or 10 kilometers. So if I understand this correctly, single mode basically shoots a single direct laser beam down a microscopic glass core, right? And that prevents the light signal from scattering.
You nailed it, yeah. By keeping that beam perfectly focused, the massive amount of data stays completely intact across literally an entire city.
It's like having a hyper-fast, invisible extension cord stretching across an entire city.
That is a great way to look at it, yeah.
But wait, let me push back on something here. Because physics still exists, you know?
Last time I checked, yeah.
Right. Light traveling through 6 miles of glass still takes time. So how can this spec sheet claim effectively zero lag?
Huh.
I mean, I can just download free remote desktop software right now. Why would an infrastructure company drop like $2,500 on this specific hardware box to do the exact same thing?
Well, what's fascinating here is that standard software and this hardware, they're playing 2 entirely different games.
How so?
So with standard remote desktop software, your computer has to capture the screen, hand it to the operating system, compress it, package it, and then finally send it over the network.
Right, so it's like your data is stopping at a toll booth at every single step of the software process.
Exactly. That is a perfect analogy.
Yeah.
And the computer on the other end has to go through those same toll booths in reverse just to display the image.
Ah, so that's where the lag comes from.
Yeah, that software overhead is what creates that dreaded input delay. You know, the mouse cursor trailing half a second behind your hand. But this Smart-AVI device, it operates purely at the hardware level using ultra-low latency JPEG 2000 compression.
Wait, so it completely bypasses the operating system?
Yeah.
It's basically ditching the toll booths and taking a dedicated express lane.
Yes, completely. I mean, JPEG 2000 is this highly efficient compression standard that was originally designed for digital cinema.
Oh, wow.
Yeah, so the hardware chip inside this extender grabs the raw DVI video signal directly from the graphics card. It mathematically shrinks it down in real time and just fires it over the network. It completely ignores whatever OS the server's running.
That explains it then. I mean, that millisecond difference might not matter for checking an email, but think about the scale here. Out of the box, this platform manages 64 servers. And if you add their SmartAVI P2P manager, it scales to an enterprise matrix handling 256 servers and 32 simultaneous users.
Which is huge. And if we connect this to the bigger picture, we're talking about a grid operator switching a power relay miles away, or, you know, a traffic control center managing a city's intersection.
Relax. High stakes.
Exactly. A software freeze or a half-second mouse delay in those scenarios isn't just annoying, it's potentially disastrous.
That completely changes how I view the price tag, because at $2,549.15, obviously you aren't buying this to just work from your couch. And looking at this reliability rating, the MTBF, the mean time between failures It's listed at over 135,540 hours.
Yeah, and if you translate that into human time, you're looking at over 15 years of continuous, unbroken operation.
That is insane.
It is. You aren't just buying a network extender, you are buying the absolute certainty that when you move your hand, a machine 6 miles away reacts right that very millisecond.
Which leaves you with an incredible thought to kind of wrap up on. If we already have the underlying hardware to completely bypass software toll booths and allow flawless, zero-lag operation of physical machines from 6 miles away, how soon until highly tactile, hands-on professions become entirely remote?
It's a crazy thing to consider.
Truly, just imagine complex manufacturing or even emergency disaster response operating purely through that 6-mile express lane. Just something to think about next time you're stuck waiting for a simple video call to buffer.